have to talk about uncertainty principle. The statement of uncertainty principle is, it is impossible to measure simultaneously and accurately the values of particular pairs of dynamical variables which describe the motion of an atomic system. If you measure one quantity, there is some error in calculating another. Anyway, the product of errors is greater than or equal to h cross by 2. This is the statement. First of all, we should know the meaning of the term dynamical variable. We know that position and momentum are the dynamical variables used to describe the motion of an atomic system. You know that x is position, p is the momentum. These two are called dynamical variables. With the help of these two dynamical variables, we can describe the motion of an atomic system. If you want to measure these two variables at the same instant of time, we cannot record them accurately. If you measure position first, there is some error in calculating momentum, or if you calculate momentum first, there is some error in calculating position. Anyway, if you consider delta x is error in calculating position and delta p is error in calculating momentum, the product of errors is at least equal to Planck's constant, or the product of errors is greater than or equal to h cross by 2, where h cross is h by 2 pi. H cross equal to h by 2 pi. This is the statement. It is impossible, that means not possible, to predict or to record at the same instant of time the values of particular pairs of dynamical variables. Here position and momentum are the pair of dynamical variable which are used to describe the motion of an atomic system. If you measure one quantity, there is some error in calculating another. If you measure position in the accurate way, automatically there is some error in calculating the momentum. Or if you calculate momentum first, there may be some error in calculating position. Anyway, the product of errors is greater than or equal to h cross by 2. Delta x is error in calculating position, delta p is error in calculating in momentum. The product of errors is greater than or equal to h cross by 2. Now we have to provide the optimum explanation for this statement. Now go to the next statement. Within the wave packet, the particle is likely to present where the amplitude of the wave function is large and the probability is small elsewhere. First of all, we should understand this statement. For that, we should draw a wave packet. Say wave packet is an envelope which contains more number of waves. Say this is a wave packet. It is an envelope which contains more number of waves. Say the waves are shown like this. See here, this is the wave packet which contains a number of waves. Say, go to the statement. Within the wave packet, the particle is likely to present where the amplitude of the wave function is large. See the region with the maximum amplitude. See the probability of occupation probability is more only in this region. Now go to the statement. within the wave packet, this is the wave packet, the particle is likely to present where the amplitude of the wave function is large. Say this is the region where in which the amplitude of the wave function is maximum. But if you consider these regions here, the amplitude is very small, the wave function is having lesser amplitude. Within the wave packet, the particle is likely to present where the amplitude of the wave function is large and the probability is small elsewhere. Rest of the places, the probability of finding the particle is very small. Now go to the next statement. If the size of the wave packet is small, only a few waves have maximum amplitudes. This is a smaller wave packet which may have only 2 to 3 waves with maximum amplitude. Therefore, easily we can define where the particle is. If the size of the wave packet is very small, only few number of waves are having maximum amplitude, the particle is likely to present where the amplitude of the wave function is having maximum value. So easily we can predict the position of the particle. At the same instant of time, there is some error in calculating momentum. According to de Broglie, the wavelength of the de Broglie wave lambda equal to h by p. Therefore, momentum p equal to h by lambda. Momentum of the particle is Planck's constant divided by de Broglie wavelength. The concept wavelength is recorded accurately if the waves are having almost equal amplitude. If the size of the wave packet is very small, only few number of waves are having maximum amplitude, so the lambda is poorly defined. The lambda is the distance between the two equal peaks. Here only 3 peaks are present, so lambda is poorly defined. Only one wavelength we can record. This is lambda. We cannot record the distance between these two as lambda. So that if the size of the wave packet is very small, only few number of waves are having maximum amplitude. The lambda is the distance between two equal peaks. Only few number of peaks are present like this, so that lambda is poorly defined. Here lambda is poor, wavelength is poor. If wavelength is poor, momentum is also poor. So the error may be occurred in calculating momentum. So in this case, x is accurate, but momentum is not accurate. Some error is occurred in calculating momentum of the particle, that is delta p. Now go to the next statement. If the size of the wave packet is large, more and more waves have maximum amplitudes and hence the position is poorly defined. On the other hand, the momentum is well defined because of the appreciable wavelength. See here, if the wave packet is very large, say that draw a wave packet like this. If the size of the wave packet is very large, then we can have waves with maximum amplitude at many places. See that waves are drawn in the accurate aspect. I am very sorry, I am poor in doing this because of the pad is not supporting me to draw this diagram. Almost we are getting the structure. See this region here, we can point out more and more waves with equal amplitude at least. Say this region are having waves with the maximum amplitude, so the particle is likely to present in this region 1, 2, 3, 4, 5, 6, 7, 8 like this. So if you want to find out the position of the particle, we have to face little bit trouble because more and more waves are having higher amplitude. Here x is poorly defined. because of the larger size of the wave packet. But at the same time, lambda is well defined. So the peaks are almost similar. So the lambda is well defined. The wavelength is well defined. But x is poorly defined. So if the size of the wave packet is very large, the error is occurred in calculating position, but lambda is well defined, so momentum is well defined. Anyway, the product of errors in calculating the position and momentum is greater than or equal to h cross by 2. We may apply the same to another set of variables, energy and time, angular momentum and angle. Say delta E into delta T greater than or equal to h cross by 2. Delta J into delta theta greater than or equal to h cross by 2. These variables are called canonically conjugate variables. Position, momentum, energy, time, angular momentum and angle are called canonically conjugate variables. These variables are not subjected for commutation, which means that xp not equal to px. xp minus px is having some value, that is IH cross. So these variables are not commuting variables. So in this way we have to realize the uncertainty principle. In quantum mechanics, single particle motion is expressed in terms of wave packet rather than a single wave. So the size of the packet describes the error in calculating position and momentum. Anyway, the wave function may be real or complex, but the probability of finding the particle is a real entity. See here, the wave function may be a complex quantity, real or complex. Say psi equal to a plus ib. It is a complex wave function. This is real part, this is imaginary part. Then the complex conjugate of the wave function psi star is equal to a minus ib. Just we have to change the sign of phi. But the P of r comma t, probability of finding the particle is a plus ib into a minus ib, which is our psi star psi or observed square of psi. This is the formula for P of r comma t. P of r comma t is psi star psi. Say if you multiply, we can get a square plus b square. See, a square plus b square is the answer, which is also a real entity. Multiply this a into a square plus ib into a, then a into minus ib, then I into I square minus 1, already one negative sign is present, so plus b square. So the product of a plus ib into a minus ib is a square plus b square. It is a real entity, which means that the wave function may be a real quantity or complex quantity, but the probability is a real entity, which means that the particle is compulsorily present inside the packet, whether the wave function is a real function or a complex function, but the probability of finding the particle is always a real entity. This is the outline of our uncertainty principle.